All right, so today we're looking at graphing absolute value functions. So first thing we need to do is we need to talk about what the different pieces and parts of an absolute value function are. All right, so I'm going to tie this back to our slope-intercept formula, which is y equals mx plus b. And I'm going to show you how these, the regular slope-intercept formula and an absolute value formula are very similar. So you'll see that some of the pieces directly apply, all right? So looking at it first, let's look at our a first. What you'll notice is right here in front of our x, right? Remembering in our slope-intercept formula that the number right in front of the x is slope. This is a very similar function in the absolute value, and that this is the slope of the right-hand side. This will make more sense when we go actually graph it, but bear with me, all right? Slope of the right side. All right, next piece I want to talk about here is this k. All right, you notice this says plus k. This k over here works exactly like, well, not exactly like, but very similar to our plus b. So in our absolute value, in our slope-intercept form, the plus b here was our y-intercept. It's what shifted our graph up and down on the y-axis. K behaves similarly. It shifts the graph up and down. And I specifically say vertex here. More on that in a minute. So it shifts the vertex up and down. All right, now the last piece we have here is something that we do not have in our slope-intercept form, and that's this h. All right, we don't have it in our slope-intercept form because the slope-intercept form only shifts up and down. All right, we have it here because of the shape of an absolute value graph. This piece, this h, shifts our vertex. So it shifts the graph, specifically the vertex, right and left. All right, and for this, it is important to know that because of this minus sign here, it goes backwards. So you shift to the right when you have a negative h, you shift to the left when you have a positive h. All right, more on that in just a minute when we actually graph it. Let's scroll down and let's look at what we're doing here. What it's saying here first is find the vertex of each of the following absolute value equations. First off, we need to look at what does an absolute value equation look like? What does the graph look like? Well, the very basic graph for an absolute value, let me just draw my axes here, looks just like this. All right. Remember with slope-intercept form, we had our parent graph, we said that was y equals x, and it just went diagonally from the top right down to the bottom left. Absolute value is very similar to that. The difference being I only have this piece. All right, and then we mirror it across the y-axis. So absolute value graphs are going to be a V, and this is why we talk about the slope of the right-hand side being this A part right here. So it is this slope, and then we mirror it on the opposite side. So when we're talking about our vertex, the vertex of the parent function, which would be y equals the absolute value of x, the vertex would be at 0, 0. So when we're talking about shifting the graph, shifting the vertex because of our h and our k, we're shifting it from 0, 0, from the origin. Okay, so let's look at this, our first example. We have y equals the absolute value of x minus 7 plus 8. All right, so this says that I am going to shift my vertex 7 places to the right. All right, remember we said that negative means it goes to the right, and then I'm going to shift it up 8 places. So if I started at the origin, which is 0, 0, if I went right 7 and up 8, what is my new coordinate? It's 7, 8. All right, similarly, we're just writing the vertex here, so I need to look at my positive 2 and my negative 6. Positive 2 says go left 2. So negative 2, I went left 2, go down 6. All right, next. This is just the absolute value of x here, right? So I could say that this is x plus 0. So I didn't shift right or left any. So that's 0. And then I went up 3. So really, we're looking at the numbers that tells us how far we shifted, and we get our vertex points from there. All right, next we're going to graph each of our absolute value equations using the information that we have. All right. The first thing that it's asking us is about the opening. Remember I said that an absolute value graph is open? It looks like a V. All right. When it's positive, just like when you're graphing a quadratic equation, you remember the parabolas from Algebra 1? All right. When it's positive, right here, when A is positive, it opens up, just like this. When it's negative, it's going to open down. So this is a positive opening, this is a negative opening. All right, so looking at our first one here, y equals the absolute value of x. This is positive, so it is going to open up. This is our parent graph, as discussed before, so it starts at 0, 0. All right, next is talking about wide, narrow, or standard. This is talking about how wide the opening of our V is. Our V, our graph, what it looks like. All right, this is the parent function. So by definition, it is standard. It is what we base everything off of. So now let's actually graph this. We know our vertex is at 0, 0. And our slope here, which remember is the slope of our right-hand side, we don't have a number here, so it's going to be a ninja 1. Okay, so the slope of our right-hand side is 1 over 1. So we're going to graph that. Start at our origin, go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, and so on. If we continue to draw dots, we get all the way to the corner. Okay? Now we need to do the same thing. We need to mirror this on the opposite side of the vertex. Okay? So instead of going up 1, right 1, we're now going to go up 1, left 1. All right, and we can keep drawing dots, and we're going to get all the way to this corner. What I want you to see here is that if I were to draw a mirror, if we had a mirror running right straight down through the vertex here, that the left side looks the same as the right side. You see how they're mirror images of each other. All right, so next let's work on our next one. Y equals 2 times the absolute value of x minus 1 plus 3. We're still positive, so this is going to open up. Why are you still red? Change to blue. All right, the vertex, we're shifting. All right, so we shifted right 1 and up 3. So my vertex is at 1, 3. Now we need to talk about wide, narrow, or standard. So let's think about this for a minute. The slope of my right-hand side is 2. The standard slope is 1. So let's look at this. Let's actually graph it, and we can talk about it easier then. I don't want to put that on the origin. Let's put our vertex first. So our vertex is at 1, 3. And my slope of my right-hand side is 2, which means I'm going to go up 2 and to the right 1, up 2 and to the right 1, up 2 and to the right 1. We're going to mirror that on the opposite side of the vertex. So I'm going to go up 2 and to the left 1, up 2 and to the left 1, up 2 and to the left 1. Let's go ahead and draw our lines in here. All right, now I'm going to get another color. Let me grab this red. And we're going to graph the standard one on here, which the slope of the standard one was 1, right? So up 1, right 1, 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 and so on. Do you see, and I'm not going to draw the lines here because I think the dots are visual enough. Do you see the difference here? This one is clearly more narrow. All right, remember rise over run is going to rise up 2 but only go out 1. So if it's rising more than it's running, it's going to be narrower. So if you've got a whole number bigger than 1, it's going to be narrower. All right, next let's look at the next one. Y equals negative 1/3 times the absolute value of x plus 4. All right, well this is our first negative one, which means our opening is going to be down. Our vertex, we shifted to the left 4, so negative 4. We didn't shift up or down any. I've got nothing here. So that's going to stay at 0. So my vertex is at negative 4, 0. And we'll talk about this wide, narrow standard in just a minute. All right, so let's get our vertex in. So negative 4, 0. So right here, the slope of our right-hand side is negative 1/3, which means that I need to go down 1 and out 3. Down 1 and out 3, down 1 and out 3. Can you already tell whether this is going to be wider or narrower? So let's mirror it on the opposite side of the vertex. So I need to go down 1 and left 3, down 1 and left 3, and then I'm at a graph. And I bet you can already tell without me even drawing the standard 1, 1 graph on here that this is definitely wider. Okay, so fractional numbers, numbers that are less than 1, it's going to be wider. Whole numbers greater than 1, anything greater than 1 is going to be narrower. All right, so I'm not going to do D here. Let's actually scroll down, and I want to get you a good one. Let's look at H. All right, H we can't graph yet. In order to graph these, we have to have them in the correct form. I have to have it solved for Y first. So this needs to be in the form of Y equals something. So let's get rid of all the stuff over here with this Y so that we can have it in the proper form to graph it. So first I'm going to add 2 to both sides. So it leaves me with 3y equals 4 times the absolute value of x minus 1 plus 6. Now I need to divide both sides by 3. I'm going to borrow some space over here to the left. So that's going to give me y equals 4/3 times the absolute value of x minus 1 plus 2. Because 6 divided by 3 is 2. Right, now we can graph that, right? So let's see, what do we know about it? Our vertex is going to be at +1, 2, because this says I shifted right 1. This says I shifted up 2. All right. We know our slope of our right-hand side is +4/3. This is actually bigger than 1. 4/3 is more than 3/3, which is 1 whole. So this is actually going to be narrower. The other thing we need to discuss is it open up or down? Well, the 4/3 is positive, so this opens up. So I'm going to have something that looks kind of like this when I get done. All right, so let's start. Put my vertex first at 1, 2. My slope is 4/3, so I'm going to go up 4, 1, 2, 3, 4, and out 3, 1, 2, 3. Up 4, 1, 2, 3, 4, out 3, 1, 2, 3. I'm going to do the same thing on the opposite side. Go back to my vertex, go up 4, 1, 2, 3, 4, out 3, 1, 2, 3. Up 4, out 3. And then I can draw my line. All right, and that is really all there is to it. So not too bad. The last thing we need to discuss today is, besides graphing linear equations, we need to do linear inequalities. Don't panic, this is not bad. You graph them exactly the same way, you just have to add 2 more things. So we need to talk about solid or dashed lines, S-H-E-D, there we go, and whether we shade above or below. All right, so let's talk about this. Just like in a regular inequality, when we don't have this absolute value thing to work at, when we're talking about just slope-intercept form. All right, you have a solid line when you have greater than or equal to, or less than and equal to. You have a dashed line when you just have greater than or less than. Once again, you shade above for greater than. You're going to shade below for ones that are less than. And that's whether it's greater than or equal to, or less than or equal to. All right, so shade above, greater than, below for less than. Okay, so let's analyze these. Let's just go through and analyze this. Looking at the first one, does it open up or down? Well, it's negative, so it opens down. My vertex, I shifted left 3, down 2. So my vertex is at -3, -2. I only have a greater than, so my line is going to be dashed, and because it's greater than, I'm shading above. All right, so let's get some points on here. My vertex is at -3, 1, 2, 3, -2. My slope of my right-hand side is -1. That means I'm going to go down 1 and right 1, down and out. Down 1, out 1, down 1, out 1, down 1, out 1. Same thing on the opposite side, down 1, out 1. If we were talking about the opening on this, this would be a standard opening. It's just opening down instead of opening up. So I draw my lines. But look, did you notice that I forgot it needs to be dashed? So let me grab my eraser here and let's make this line dashed, shall we? All right, so now it's a dashed line. Going back, I need to shade above. So looking at the vertex, okay, look at the vertex. What is above the vertex? Well, that's here. All right, so I'm going to shade everything on that side. All right, next, let's do the next one. Our opening, we're going to open up. So it's opening up. Our vertex is at 1, 3. We're going to have a solid line, and I'm shading above. When we're doing quizzes and tests, unless it specifically has this information here where it wants you to select it and write it down, you do not actually have to write down all of this stuff. All right? If you know it well enough that you can go directly from the equation to the graph, go for it. I'm writing it down now for emphasis just so you can see what I'm thinking. So my vertex, is at 1, 3. My slope of my right-hand side is 2, which means I'm going to go up 2 and out 1. So this is going to have a narrower opening. Go back to my vertex, go up 2 and out 1 the opposite way. Draw my line, which is solid, so I don't have to go back and erase and make this dash, and shade above. All right, the last two are more of the same. You just have to solve for y here first. Last thing we got to talk about is comparing each of the equations below to the parent function. So this is going from y equals the absolute value of x. What did it do? All right, well, my opening is up. My stretch, look here, that has to do with my opening. Is it wide, narrow, or standard? For bigger than 1, so this is going to be narrow because it rises more than it runs. Which way did it shift? Well, right here, it shifted left 1. So it shifted left 1, and it shifted up 3. All right, same way on this one. Opening, well, it's down because it's negative. Its stretch, pay attention here because this is a fraction, and your instant reaction is going to say, well, this is wider because it's a fraction. But look, it's an improper fraction. This is 8/5, which is bigger than 1. So this is not going to be wider. It's actually going to be narrower. It shifted left 7, and it didn't shift up or down any. So this is none. All right, finally, the last thing they're going to ask you to do is compare two equations. So when I started out here, and then I moved to here. All right, so let's look. Our opening. This is asking if we're opening up or down, and did it stay the same or did it change? Well, my left one is positive, my right one is negative. So my opening is definitely different. My stretch. Are they wider? Is the second one wider, narrower, or the same as the first one? Well, the slope of my right-hand side is 2, 3 for each one of them. So my stretch is the same. I have no change in my stretch. Shift. All right, so look at this, left, right, or 0, or none. All right, so right here, my left, I started out with 0. I started out at 0. I started out where x equals 0. And then I moved left from 0 5 places. So I shifted left 5. All right, for my vertical shift, up and down, I started out, and let's just envision this. All right, I started out at -4, and then I moved down to -7. So how far did I move? Well, I moved down, number 1, and how far? Well, I moved 3. So I moved down 3. All right, let's do our last one here, and then we'll be done. All right, so the opening, this one is negative, this one's positive, so it's different. My stretch, I went from a 7/3, 7/3, which is bigger than 1, so I had a narrow stretch, to 1 here, which is a standard stretch. So if I go from narrow to standard, my second one is definitely wider. Shifting left, right, up, down. All right, so I started out, again, I'm going to draw my little graph here so we can envision this. I started out where my x was at 1 space to the right. All right, this one, you notice that it doesn't have anything, so its x is going to be at 0. So how far did I shift? I shifted 1 place to the left. Now let's talk about our up and down shift. I started out at -5, so down here, and then I moved to +9, which is going to be up here. So I moved up for sure, but how far did I move up? Well, I moved 5 from here to here, and then another 9 from here to here. So 5 plus 9, I went up 14. All right, that is actually it for today. So good luck with your homework, guys. As always, email me if you have any questions. Have a great day.